So now let's think about what do we do when we have three equations and three variables. So this system has x1, x2, and x3, and we have three equations. So we want to still think about the elimination method, and the variable I want to eliminate is going to be this 5x1. Okay, so let's use our same method and see if we can get rid of this 5x1. I've got a 1 times x1 in the first equation, so let's multiply this guy by negative 5. So I'll just go ahead and do it here. So negative 5x1 is going to be plus 10x2, and then minus 5x3 equals 0 times negative 5. And if I add that to the third equation, if I add these, I'll get 0 for x1, I'll get 10x2, and negative 10x3 equals 10. Also notice that this equation is equivalent to x2 minus x3 equals 1, right? So I could divide both sides by 10, and that would further simplify it. So here, I'm going to rewrite my system and I'm just going to replace the third equation. Right, I wanted to eliminate this guy, this x1 in the third equation, and that's what I did. So I'm just going to rewrite my system to show that I have accomplished that. And I'm going to next I want to eliminate this x2 from the third equation. So I'm going to do something clever here. Do you agree that if I were to switch the order of these equations, the solutions don't change, right? So if I write the third equation as the second equation and the second equation as the third equation, if I just swap those two, the system's the same system, right? It doesn't really matter what order these are in, but now I still want to eliminate the x2 from the third equation. And I'm going to use the second equation to do that, right? So if I multiply this by negative 2 and add to the third equation, then that'll eliminate this 2x2 in the third equation. So I'm going to write that to the side. So I'm going to multiply this by negative 2. Right, so this will be negative 2x2 plus 2x3 equals negative 2. And I'm going to add that to the third equation. I'm going to do my addition problem here. And that eliminates x2. Here it looks like I get negative 6x3 equals positive 6. And this gives me x3 equals negative 1. So again, I'm going to rewrite my system to show that I eliminated that x2 from the third equation. So this will be x1 minus 2x2 plus x3 equals 0, and then x2 minus x3 equals 1. And then the last equation just says x3 equals negative 1. So this is kind of a standard form that we like. When we have more than two equations, we have what's called triangular form. So I've eliminated the first variable from the second equation, and the first and second variables in the third equation. And it creates this triangle, right? So the triangle's here, right? What's nice about this is if we were working this problem this way, now I could plug in x3, because I know it's -1, right? So I plug in x3 equals -1 into the second equation. And because there's only two variables, I can solve for the x2 variable. And once I solve for the x2 variable, I can plug in x3 and x2 into the first equation, and the only one left is x1, and I can solve for x1. So this process of starting from the bottom and substituting up the chain, right, till you get to the top equation, this is called back substitution. This is called back substitution. So I'll do it real quick here. So I'm going to plug in -1 for x3 into the second equation and solve for x2, so I get x2 equals 0. And then I'm going to plug in x2 equals 0 and x3 equals -1 into the first equation. This is 0, and then this is -1 equals 0, so I get x1 equals 1. And here I found all three variables, so I'm going to write them in an ordered triple: x1, x2, x3. Right? You know, in calculus 3, you might call it x, y, and z. I wrote down the wrong variable. You might call it x, y, and z. We're just going to say it's x1, this is x2, this is x3. Right? So there's our solution.